Great. Thank you for tuning in. It sounds like there's one person who's having some trouble hearing me, but it looks like all the others can hear, and we've got some people from Camano and Whidbey. So thank you very much for joining us this evening. My name is Catherine Wells. I'm with the Camano Wildlife Habitat Project. The Camano Wildlife Habitat Project is a volunteer organization based on Camano. It's supported by the Friends of Camano Island Parks and the National Wildlife Federation. Our mission is to create an island in harmony with nature 1 yard at a time, meaning that what we do is we encourage people to change or enhance their landscaping to provide food, water, cover, and places to raise young for wildlife, and that through our developed areas, and that creates corridors between the natural areas on our island. So we've got our parks, but we've got a whole lot of residences in between our parks. So what we want to do is create everything that wildlife needs so that they can travel up and down and find whatever they need here on the island and not just in a tiny little park. It helps provide a little buffer for them, and it provides enjoyment for us because we get to see more bees, birds, and butterflies. We have a monthly education program usually, but COVID has changed some things. So we're going with webinars when possible. Please keep checking our website. Camano Wildlife Habitat is what you would Google, and it'll bring up the website. I think it's camanowildlifehabitat.org. And then we can, we'll keep you posted on what's coming up. We do have a program next month with Kevin Zobrist, another WSU Extension educator, on why so many of our trees have been dying recently. But tonight, we have Jerilyn Ritzman, who is a Camano Island native, and she lives on Camano as well. She is our Shore Stewards Coordinator for WSU Extension Island County, based on Camano. She also helps manage WSU Extension Wastewise and Master Gardener programs. I'll let her tell you a little bit more about herself. She has a very interesting background and has done some wonderful research. And then we'll get into our program, which is Camano Island Sound Habitats in our backyards and beyond, how everything connects. And if you have any questions, just a couple of housekeeping bits. At the bottom of your screen, you just need to float your mouse down to the bottom of your Zoom screen. You'll see the chat button, as most of you have already found that, but if you just tuned in, the chat button is where you will add your questions. We will answer them at the end, but know that if you add a question, I'm going to keep an eye on everything and we'll answer those at the end. If you're having technical difficulties, also chat. Let me know, and I may be able to help you troubleshoot. Does anybody have any questions? I'll look at the chat here real quick. Otherwise, we'll get started. Okay, everyone, thank you. And it's off to you, Jerilyn. Thank you.
All right, thank you, Catherine. Thanks everybody for being here. I'm excited to get the chance to present to you tonight. For those of you who are familiar with Camano Wildlife Habitat Project, and as Catherine said, you attract wildlife by providing food, water, shelter, and a place to raise young. And so that applies in our backyard properties. That also applies in the nearshore environment. And you also probably know about sustainable gardening practices like water and soil conservation, controlling invasive species, limiting chemical use. All of that applies to the nearshore as well. So the goal tonight is to talk about a environment that you might not be as familiar with. So I'm going to start sharing my screen for the presentation now. All right, is that showing up for everybody? Good, okay. So I'll start off by saying I am by no means an expert in marine nearshore ecology. My educational background is in geology and then marine affairs, which is a lot more law and policy oriented than it is science. But I've now been in this position for just over a year, and I've picked up a lot along the way and have done some research. So I've put together a very broad overview for you guys tonight that I hope you find enjoyable. I'm going to start by going over the geography and geologic history in the region. Next, I'll talk about shoreline processes, the nearshore habitat zones, the biology that we can find in the nearshore environment, and finally connect it back to us and the impact that we have on the nearshore environment by going about our everyday lives. And finally, I'll talk a little bit about the Shore Stewards Program and what that's all about. So first, to get us oriented, we are a part of the Salish Sea. That is the body of water that combines the Strait of Georgia, the Strait of Juan de Fuca, and our home Puget Sound. This term was first introduced in 1988 by a marine biologist, with the understanding that these bodies of water don't live independently. There's constant play between the three of them, and that this region is just one giant ecosystem or watershed. So how did Puget Sound get to be the way it is? Well, Puget Sound is a natural basin just because it's situated between two mountain ranges, the Olympic Mountains and the Cascade Mountains, but it used to be just more like a river valley than what we see today. The modern Puget Sound that we know today was created in the last ice age. Earth, over the last 4.6 or so billion years, has fluctuated between two conditions: icehouse and greenhouse conditions. We're actually in icehouse conditions right now, which just means that we have ice on our poles. So when we think of the ice age, what we're really thinking of is just the most recent of several, probably at least 6 or 7 glacial maximums over the last 2.5 million years, which is how long we've been in our current icehouse. The last glacier retreated by about 15,000 years ago, but at some points and in some areas, it was the height of about 5 Space Needles stacked on top of each other. So this ice came down and it carved out Puget Sound through friction of the ice and also through outflow of melting water. And so that has left us with this fjord-like system that we have today, where we have predominantly unconsolidated glacial till or glacial deposits lying on top of bedrock. You can see in the map here that it's almost entirely this quaternary. That's just the name of the period of the last ice house of the last 2.5 million years. So mostly we just see deposits from glaciers in this area. So focusing on Puget Sound, there isn't really a clear boundary for it. Most people I think consider it to go all the way up north to the Canadian border. Some people consider the northern extent to be the top of, or the northern extent of the San Juan Islands. But overall, Puget Sound covers an area of about 2,800 square miles, and that's within a watershed covering 17,000 square miles. So zooming in more, we have the Whidbey Basin. It's one of 5 basins that we have in Puget Sound. Going back a slide, it's the Admiralty Inlet Hood Canal, Central Puget Sound, and South Puget Sound. So we are the northernmost one here in the Whidbey Basin. And surrounding Camano, we have 4 main bodies of water. To the north, we have Skagit Bay. To the east, we have Port Susan. To the south, we have Possession Sound. And to the west, we have Saratoga Passage. Now, 3/4 of these are at the mouths of rivers, which are carrying sediment into Puget Sound. So we'll learn along the way tonight that those environments are a lot different than Saratoga Passage, which isn't as fed by river sediments. So I'll move on now to shoreline processes. You can see in the diagram here that shorelines are very complex. There's a lot of different things going on, creating a lot of different landforms. But tonight I'm going to focus on 3 main shoreline processes: feeder bluff erosion, river sediment loading, and drift cells. So we'll start with feeder bluffs. Feeder bluffs are bluffs that have been carved out through the glaciers in Puget Sound and now leave these really dramatic cliff sides where wave action, wind action, and gravity erode away the cliffs, and the resulting sediment feeds the beaches lying below. You can see in the map here that we have several feeder bluffs around Camano Island. We have exceptional feeder bluffs, which provide more sediment. Those are mostly located on the south end. You can see in the picture to the right, that's an example from Camano Island State Park, where there's a lot of exceptional feeder bluffs. And then we also have zones in the light blue, where sediment is not really eroded or deposited, but it's transported. And then in the yellow is where a lot of the accretion or sediment deposit occurs. So second is river sedimentation. You can see in the map to the right by the size of the arrows that represents the magnitude of the amount of sediment being deposited into Puget Sound each year. All of these rivers together contribute about 6.5 million tons of sediment on average per year into Puget Sound. And that seems like a lot, and it is, but it's also important to note that these are actually kind of small rivers, and that the Fraser River to the north, it alone produces 20 million tons per year. And that's because it has a lot of tributaries that are draining into it, and it starts all the way in the Rocky Mountains. So that's a lot of area to cover where it's picking up sediment along the way. It's also interesting to note that the three rivers in Puget Sound that have the highest sediment load, all their headwaters all originate on glaciated volcanoes. And so the top three there are Skagit River, Nooksack River, and then third is the Puyallup River. And I believe that the Skagit River is as high as it is because it originates not just at one volcano, but actually at two. So the headwaters there originate at Mount Baker and also Glacier Peak. Glacier Peak used to drain into the Stillaguamish River, but an eruption and subsequent lahar blocked off that path, and now it follows the Sauk River up to the Skagit. So when all of that sediment reaches the mouth of these rivers, it creates these delta plateaus that we can see here. This map is a digital elevation map. The topography that's shown on land is taken by LIDAR, which stands for light detection and ranging. And that happens when a plane flies overhead and shoots lasers down to the ground. And these lasers can penetrate vegetation and then bounce off of the ground and then go back up to the plane. And so that tells us the elevation. And then it also shows the elevation underwater, which instead of being called topography is called bathymetry. And they determine that by using a boat and doing swaths back and forth and using sonar to bounce off the bottom of the ocean and then get that elevation profile as well. So you can see, especially in Port Susan and up north in Skagit Bay, that these have been very filled in by river deposits. Another interesting thing, going back to the Ice Age and the glaciation, you can see these vertical striations on the land. That's actually where glaciers have come down and carved through the land, creating these stripes. So finally, we have drift cells. This is what happens when there's an area on the shoreline where wind is eroding one area, transporting along another, and then depositing in a third location, all kind of adjacent to each other. Depending on wind direction, these can either go from left to right or right to left. And when you have two adjacent drift cells, they can either diverge, leading to a lot of net erosion, or they can converge and lead to net deposition and create landforms like spits. This is why you often hear about shoreline armoring as well, because that development along the shore can disrupt this whole process, where you might have had a feeder bluff before or something like that, where it's creating sediment and eroding it. It might block that, and it just changes the whole process. So now I'll talk about the nearshore habitat zones. Starting from the furthest inland, we have the upland, the supertidal, intertidal, and subtidal. And depending on who you're talking to, you could also hear terms like supralittoral, which would be in place of supertidal, midlittoral instead of intertidal, and sublittoral instead of subtidal. And the word littoral just means relating to the shoreline. So supra is above, mid is in the middle of it, and sub obviously below. This is important to note because in the subtidal or sublittoral zone, it can go all the way out theoretically to the continental shelf, although that doesn't really apply in the Puget Sound. But another way to think of it is that it covers the entire neritic zone, which is where light can penetrate the ocean water all the way to the seafloor. And that happens at about 200 meters depth. So that actually applies to most of Puget Sound. The average depth of Puget Sound is about 62 meters, which is only 205 feet, and the maximum depth is 370 meters, which is 1,200 feet. So a lot of the Puget Sound could technically be called sublittoral, and therefore subtidal, and therefore nearshore. But for the purposes of this talk tonight, we'll focus a little bit closer to the shoreline. So we'll start with the backshore or the upland. In the diagram at the bottom, it shows it as forested, but it can be a lot of different environments. It could be your feeder bluffs, it could be salt marshes. You can see in this picture here, which was taken from the Iverson Preserve, that it can be much more like salt marshy, which drains quickly. This is also the zone that has seen the most alteration through development, because instead of these marshes or forests, you'll see houses, piers, and other development. The lower boundary of this zone is the driftwood logs, which you can see about 2/3 of the way up the picture. And this is also where sediment sources occur, the feeder bluffs, the river sediments, and so on. This is also an important nesting site for birds. For example, the pigeon guillemot, which I'll talk about a little bit later. Second is the supertidal. This is the zone that occurs between the log line, which you can see here in the picture, and it goes down all the way to the mean high water line. And that is just a way of saying that out of the 2 high tides that occur per day, this is the average of the higher of the 2 over a 19-year period. This area is shaded by the backshore, the upshore, and also by like the logs and other debris that occur there. And these logs also control erosion by breaking up the wave energy. However, at extreme high tides or storms, the waves can reach to the feeder bluff, and that's how we get some of the erosion. You can also see the rack, which is the seaweed lines seen here in this picture, which was taken at Barnum Point. And that is just indicative of where the high tides were of any given day. The zone is also important for insects. Scientists have found that insects are a very important part of the juvenile salmon diet, especially when they're at a stage before they can start eating forage fish. And finally, I like thinking of the supertidal as the area where you're most likely to be able to get in a walk on the beach. This is the highest up. There's usually at least a little bit of beach, unless you're like me and my mom a few times in our lives, or we haven't really paid attention and got stranded and had to do a bit of wading through the cold water. This is also a great zone for agates, which if you're into that kind of thing, this is the zone for you. Below that is the intertidal zone. This is the zone that lies between the mean higher high water and mean lower low water lines. So again, the higher of the 2 high tides and the lower of the 2 low tides per day on average. Here the substrate can vary. It can be very rocky, as you can see in this picture, or it can be more sandy and muddy, and a lot of that depends on where the sediment came from. When we were talking about river sediments, for example, as sediment is carried down the river, the heavier, bigger materials will drop out first, and the finer materials will be carried further. So if you go on a trip on the river closer to the headwaters, you'll see a lot of the bigger boulders and bigger rocks. If you go closer to Puget Sound, like for example, a beach on the river in the Sylvana Valley, you'll see a lot finer material, and by the time it reaches the Puget Sound, it's a lot muddier and siltier. So depending on where that material is coming from, either a river or a feeder bluff, it'll be more rocky or sandy or muddy. This is the area which, depending on the time of day, is either covered in water or not covered in water. And you can tell that by all of the algae that you can see here covering the ground. It's also where a lot of clams and other filter feeders hang out in the mud. So you'll see a lot of clam diggers out here on good clam tides. And then at low tide, you'll also see tide pools with all sorts of little critters in them. So finally, we have the subtidal zone, which is the zone that lies below the mean lower low water line. And the lower boundary, as I said, is kind of flexible depending on who you're talking to. So it can go all the way out to the end of the neritic zone, about 200 meters depth. This is also where you'll see a lot of the larger fish and other larger fauna compared to the other areas. And finally, eelgrass and bull kelp forests provide services for the ecosystem, like habitat for fish and crustaceans. That can include herring spawning grounds. The herring like to lay their eggs on the eelgrass blades. This also includes shelter for crab while they're molting. And it can also provide climate control for the animals that live within this region during low tide so that they don't get too warm. So moving on to the biology. This is just a nice, straightforward food web of the Puget Sound, right? It makes a lot of sense. Not really. So typically when we see a food web, we see a much more simplified version, typically in a pyramid, like you see here, where at the bottom we have our primary producers. Those are the like phytoplankton and seaweed that photosynthesize the sun's energy. And then we move up all the way to the top carnivores, like your whales, your sharks, your dolphins, etc. As the animals in the upper levels die, they get broken down by bacteria into their essential nutrients, which then are taken up again by the primary producers, and it just creates this cycle again and again and again. But it is important to recognize that it looks a lot more like this and a lot less like this. So Puget Sound is home to a very diverse biology. We have over 200 species of fish, over 100 species of birds, 26 different marine mammal species, around 7,000 species of marine invertebrates, including the giant Pacific octopus, which is the world's largest octopus, as well as upwards of 70 kinds of sea stars. And it's also home to a great foundation to the food web through the primary producers and the plant life, or algae. So we have over 625 kinds of marine algae and hundreds of species of phytoplankton. So one of the coolest things about Puget Sound is that we have some of the smallest organisms in the world and also some of the largest. We have primary producers, types of plankton that are all the way down to like 0.01, 0.1 millimeters in diameter, all the way to animals that are tens of meters long. Puget Sound is home to several whales in the top 10 largest animals in the world, including the minke whale, the humpback, and the gray whale. And then we also have our orcas, of course. And Puget Sound has also had some rare visits by the sperm whale and the finback, which are in the top 5 largest animals in the world, with the fin whale being the second largest next to just the blue whale. So I'll start with the primary producers. Here I'm going to focus on diatoms, although there's a lot of different kinds of phytoplankton. Diatoms are single-celled algae. They use the silica in the water around them to create glass shells. They produce 20% of the world's oxygen, which is greater than all of our rainforests combined. and they also make up 40% of marine primary production. You also, if you use diatomaceous earth in your gardens, you have these little guys to thank for that. Throughout history, phytoplankton, diatoms, when they die off, they've fallen down to the ocean floor, and that over time they get compacted and create diatomite, which is then turned into diatomaceous earth, and it's uplifted onto land over time just through tectonic processes. Diatoms can also lead to pseudonychia blooms, which produce domoic acid, and then if those are concentrated in marine organisms and then eaten, they can create amnesic shellfish poisoning. In grad school, I did a capstone project where we learned about this. We went to the coast in Washington and California, and we interviewed community members who had been impacted by the fisheries closures relating to a giant bloom. It was about the same time when the blob, as we probably heard on the news, was just sticking around and not going away along the entire US West Coast. And so it created a lot of social and economic damage to coastal communities. And this isn't just a problem on the coast, though. We've actually seen pseudonychia blooms in Penn Cove, which is just across the way in Coupeville. So it's definitely something to look out for shellfish lovers. We also have herbivorous consumers, zooplankton. The Department of Ecology in Washington State, they have the eye over Puget Sound, which flies over several times a year and documents things like this orange algae bloom here, which is called Noctiluca. It's from dinoflagellate plankton. It is non-toxic, but blooms can consume other plankton that juvenile fish feed on, so it disrupts the food web. And it can also be indicative of nutrient loading that shouldn't really be occurring, so too many nutrients coming from land into the water. This was just documented for the first time in Chuckanut Bay. So it's in new places all the time, but it's a pretty common occurrence. Another thing is that die-off from blooms can deplete oxygen levels, which again messes with the food web and other species' ability to survive. Next, I'm going to talk about forage fish. They are a key link between primary producers and the predators in the upper levels of the food chain. You can see here that there's a bit of a bottleneck. So forage fish are really a limiting factor in the ability for those predators to survive. If there isn't enough forage fish for them to eat, then their populations will go down and vice versa. So forage fish, they feed on zooplankton, small shrimps and crabs, but they're eaten by just a very wide range of animals. A lot of different fish, birds, which in turn get eaten by larger birds, and the fish get eaten by larger fish, and eventually by whales and seals, and us humans. And here, Camano Island is home to spawning grounds for many of these fish. We'll focus on 3. The surf smelt, you can see in the green, it covers a lot of Camano shorelines. The sand lance is a lot more isolated into different just pockets of the shoreline. And then we only have a little bit of herring spawning grounds, but in Saratoga Passage and in the southern part of Port Susan, there's these pre-spawning herring holding areas that they like to hang out in before they actually are ready to spawn. So this is an important environment for all 3 of those. As far as the nearshore habitat go, herring, they prefer it a little bit further out. Like I said, they like to spawn on the eelgrass beds. And then the sand lance and the surf smelt are closer to shore in the sand and gravel beach zone. If you've ever seen the smelt hitting on the shore, it's a pretty cool experience. They just are all hopping, and people can just use a net and stick it in the water and catch them. So next is salmon, one of the predators that likes to feed on these forage fish. We know salmon, obviously, because of their huge economic importance in this region, and also because they provide a food source for a lot of the larger predators, like your pinnipeds, different whales, and especially for our southern resident orcas. Our southern residents aren't like the transient orcas that come in and punt a seal 30 feet through the air and then eat that and they don't care. But our southern residents are a lot more picky, and salmon actually makes up about 95% of their diet, so the vast majority. They feed a little bit on different trouts and rockfish, but mostly they rely on that salmon. So the nearshore habitat is important for juvenile salmon as they're coming out of the rivers. They hang out in the river mouths and other areas in the nearshore until they can get larger. At the beginning, they're feeding a lot on those insects, and as they grow, they start to feed on the forage fish. And depending on the species, they can spend anywhere between like a month or 6 months in this area before they're ready to head out more towards the ocean. So the birds we have in Puget Sound, there was a study done in 2011, and they documented 172 different bird species that depend on the Salish Sea marine ecosystem for habitat or food. And of those, 42% or 72 species were highly dependent on both the marine ecosystem for both habitat and for food. The populations vary a lot just because of the migratory nature of birds, but they use these habitats for things like reproduction, migration, molting, foraging, or just overwintering during their migration. Focusing on one species in particular, the pigeon guillemot, it's been studied a lot, and it's actually become an indicator of the health of Puget Sound. And here in Island County, we have a population of over 1,000, and they're one of the only seabirds that nest on the shores of Puget Sound, and that's because they like to nest in crevices or burrows, which a lot of other birds can't do. But I remember growing up, and then actually until just recently, the only time I ever saw these birds was at the ferry dock. So my husband and I called them the ferry dock birds because we didn't know what they were. But that's the reason that we saw them all the time there, is that they can get into the crevices of the ferry docks and other piers and live happily there. So the same study surveyed marine mammals and found 37 species that depend on Salish Sea for ecosystem, for habitat and food. And of those, 29 or 78% are highly dependent. So this is everything from your cetaceans, your whales and dolphins, to your pinnipeds, your seals and sea lions, to your water-based mustelids, which is your otters, to your land-based mustelids, like your weasels, and other land-based mammals like bears, wolves, etc. So you can see here this harbor seal making good use out of this bull kelp forest, probably looking for food. So what about us? Where do we come into this? Well, through our land development, land uses, we interrupt the landscape processes, which in turn disrupts habitat conditions and creates a biotic response from organisms. Not always necessarily bad, but oftentimes bad. Our other behaviors, pollution and other things, might not disrupt landscape processes, but it can jump straight to disturbing habitat conditions and then triggering a biotic response. So why is that an issue? Well, Puget Sound population has skyrocketed. Of course, indigenous peoples have been interacting with the nearshore, living here for thousands of years, but the main disruptions to the shoreline have really happened in the time since European settlers have settled here and began developing. And then especially in the last 60 or so years, a lot more people have moved here and brought with them new technologies and development. In Island County, this is especially important because we have nearly 200 miles of shoreline around Camano and Whidbey Island. And we have the second highest percentage of shoreline parcels in Puget Sound that have been developed or slated for residential development, and 25% of our shoreline has been modified. So that's a big disruption to the nearshore habitat. On Camano Island specifically, it's a narrow island. So everybody, no matter where you live on the island, is just within a mile or two of the beach. So everything that we do on our properties, it matters. One of the biggest ways that we disrupt the nearshore environment is through the release of toxic chemicals into the marine environment. On average, between 52,000 and 66,000 total pounds of pollutants are released into Puget Sound each day. And the major pathway for most of those pollutants is through surface water runoff. There's a lot of contaminants of concern, but I'll focus on a few. The PCBs, those were produced until 1979 when they were banned, but they were mostly used for electrical equipment, as well as hydraulic fluids and lubricants and a few other things. But it's estimated that 1/2 that were produced were released into the environment. And that's an issue because they're considered a persistent organic pollutant, which means that they take a long time to break down in the environment. So they're taking up throughout the food chain. And then as things at the top of the food chain die, these things just get recycled again and again throughout the food chain. So the levels of PCBs in the environment is not as high as it was when they were first banned, but there's still a lot out there. PBDEs are flame retardants that are used in like mattress foam and other materials like that. PAHs are created through the burning of coal, oil, and gasoline, as well as trash, and then more planting materials like tobacco and wood. So when we're driving our cars, we're releasing PAHs into the atmosphere to either be deposited through falling out from the atmosphere or from surface water runoff. And this leads to the problem of both bioaccumulation and biomagnification in the food web. Bioaccumulation is what happens when a single organism is eating contaminated food over and over throughout its lifetime and gets increasingly large concentrations within that organism. And biomagnification is what happens when animals further up the food chain, they gain the pollutants that the animals that they've eaten and the animals that those animals had eaten, they just get higher and higher concentration as you get up the food chain. So as I said, most of these pollutants are carried off through surface water runoff, which is considered non-point source pollution, as opposed to point source pollution, which is where you can really just point to a location like a factory or a sewage treatment plant and say the pollution's coming from there. Non-point source pollution, on the other hand, is where this pollution is occurring kind of everywhere all the time, through things like driving your car or pet waste or plastic litter or anything like that. And this also includes atmospheric deposition and pollutants. So it's not just the chemicals that were on the previous page, but it's all these other things too that can be carried down into the marine environment. So here's a map of Camano's watersheds. A watershed can be broken down again and again and again. So the Salish Sea could be considered a watershed in Puget Sound. And then Island County watershed is a water resource inventory area, or called RIA 6. And then if you break that down even further, then you can get watersheds at an individual stream level. And you can see that most of Camano Island contains watersheds that drain eventually into Puget Sound. So each of these streams, it might drain into another stream or all the way to the Sound, but eventually, if we're polluting in any of these areas, there's a chance that it could reach to the Sound. So as we've been developing more and more land, it really disrupts the hydrologic cycle and creates more water runoff. So as we're turning forest or grasslands or anything like that into pavement, the water cannot go through that and creates more runoff. So it leads to less filtration through the soil where contaminants can be filtered out. It leads to lower groundwater flow and fluctuating water levels in our streams, and less evaporation from the land into the atmosphere. Another big emerging issue is that of microplastics. Microplastics are plastics that are 5 millimeters or less in diameter. And back, like 10 years ago or so, when we heard about these, it was all about those little micro beads in our hand soaps and our toothpaste and all of our cosmetics. But if you look at the chart to the left, those actually just make up a teeny tiny portion of the total amount of microplastics in our environment. There's also plastic film, so like your grocery bags that are breaking down, your styrofoams, your fragments that are just broken down from larger pieces of plastic. But scientists are now discovering that actually the most abundant type of microplastics in the environment is through fibers. It's estimated that 533 million plastic fibers are released from laundry into wastewater each year per average US and Canadian household, and this has profound impacts on wildlife. For example, plankton can get entangled in the fibers. They can also become ingested because animals can't differentiate between a microfiber and something that they would normally be eating. And this can lead to gradual starvation because they're not getting nutrients out of that. Or they can take up the chemicals that attach themselves to the fibers, and those can be leached into their bodies, creating other health issues. Luckily, we can reduce the number of fibers that are generated in our homes. We could do things like get a front-loading washing machine next time you're in the market for one. If we use liquid detergent, there's less friction than you would have in a powder one, creating less fibers. Also, if you use cold water in shorter cycles, that will reduce the number of fibers. You could choose more natural fibers out of cotton and other materials and less of the synthetics. You could purchase a filter for your washing machine. That's kind of a newer invention. And then just washing less frequently, obviously, would reduce the number of fibers released as well. So finally, our septic systems. I think pretty much everybody on Camano has septic, not wastewater. In several areas, drain fields can be as shallow as 6 inches below the surface of the ground. And that can lead to a greater likelihood where a malfunctioning system could contaminate either surface water or groundwater. So in response to all these things, the Shore Stewards Program was created back in 2003 because Island County just has so many shoreline residents. As part of that, a publication was created called the Guide to Shoreline Living, and that has 10 guidelines that I'll go over here in a second. Everything is grounded in science. There is a lot of research involved in everything that we produce. All actions are voluntary. It's a free program. Nothing is like regulatory. It's just for your information. So we do continued education through normally quarterly newsletters and through occasional workshops or presentations like this. So the first guideline is taking care of waste. And that's everything from maintaining your septic system to properly disposing of your pet waste. You get to learn facts, fun facts, and maybe not so fun facts, like the fact that 2.2 million pounds of dog waste are produced in Island County per year. So if that isn't properly disposed of, that leads to a lot of materials going into the sound that we don't want there. Also disposing of yard waste, household hazardous waste, and the effects that these things have on human and environmental health. Guideline 2 is working with nature. Occasionally we'll have things like rain barrel workshops, and hopefully we can do one of those again soon once in-person events are allowed again, once it's safe. We talk about keeping a buffer along the water's edge. A lot of people in Island County live atop bluffs, so we focus on that quite a bit. Guideline 3 is making wise choices when landscaping. And I'm actually going to be partnering with Snohomish Conservation District, and we're going to be holding a virtual workshop next Tuesday at 7 p.m. If anybody is interested, you could visit either Snohomish Conservation District's website or WSU Extension Island County's website, or you can email me and I can send you the information, and it's also on our Facebook page. Guideline 4, managing water runoff. This is all about understanding what happens when these contaminants reach the water, and the impacts those have on environmental health, as well as different ways to prevent pollution, including low impact development methods, which include pervious pavement, rain gardens, green roofs, etc. Like I said before, a lot of our members live on top of bluffs, so we focus a lot on bluff stability and things that you can do to reduce that. Guideline 6, living along streams and lakes. This applies a lot more in other regions than it does on Camano Island, although we do have some streams and lakes. And so it's relevant for some of those members. Guideline 7, enjoying your boat. All about how to keep your boat clean so you're not spreading invasive species, boating safely, how to watch whales appropriately, and how to crab appropriately. Guideline 8 is about conserving water in your home and garden. The EPA estimates that a third of all residential water use is used for landscape irrigation. And much of that, about half, is wasted due to overwatering or other just kind of bad practices. So we talk a lot about conserving water in your home and outside. I'm actually just about to release a newsletter to our members and on our website about xeriscaping, which is a practice of landscape methods in order to conserve water. So your alternatives to lawn, properly mulching, properly irrigating, and so on. Guideline 9 is having fun on the beach, respecting intertidal life, how to properly clam dig and follow the rules there, growing your own shellfish. And finally, guideline 10, building or clearing land near the shore, working with the contractor and planning department to do so appropriately, making sure everything is safe and that you're following permit processes. So if anyone is interested in joining the program, it's free. We do focus somewhat on things along the shore, but there are plenty of topics and things that apply to everyone on the island. So if anyone's interested in joining, you can either go to our website or email me and I can send you an application. And like I said, we just send out occasional emails about upcoming events, send out newsletters, maintain a Facebook page with relevant articles, and so on. So with that, hopefully I can answer some questions here.
I'm not seeing any questions yet. Please chat away, everyone. I'm sending out links to both the WSU Extension Island County Shore Stewards Program, to their web page, and also to the WSU's Earth Friendly Landscaping webinar, their page for it. I can also send out the Snohomish Conservation District one if you want. Either place will get you to the same spot. So. Jerilyn, I do have a question about the microplastics. Is there, what kind of research is going on? Oh, and there's another question coming up. Okay, this is, oh, fantastic. We've got a bunch of them, and it's all about the microplastics. So what is a front-loading washing machine? Why is a front-loading washing machine better? Can you explain the front-loading washer for reducing fiber? And then, yes, and then what is the, so what is the difference between how does a top loading versus a front loading washing machine affect the amount of fibers that are released into the environment?
Yeah, I think it has a lot to do with the central agitator that you have in most top loading machines. I know that there are some newer top loading machines that don't have that central agitator, so those would probably be a safer option as well. But yeah, mostly it's that central agitator.
Is there research being done on ways to remove microplastics from the environment versus, you know, preventing them from getting in? I mean, they're so tiny. I don't know how they would do that, but
Yeah, that's a really good question. Um, Not that I know of currently, but this is a really new, like, emerging issue. We didn't even really know that microfibers from clothing were a problem until a study came out back in like 2011, I want to say.
oh, that's very
And
recent.
yeah, most of the studies, actually, if anybody's interested, I did a newsletter about this that can be found on our website, and it released in spring. That was my most recent one. And it talks about a lot of this in a little bit more detail. But many of the studies that I cited for that only happened in the last like few months or few years. So now that the problem is better identified, I think that those technologies will be coming down the road. Finer meshes in wastewater treatment plants. There's research going into whether septic systems are susceptible to this problem. I would imagine that they are, because if these fibers can get through wastewater treatment plant filters, it makes sense that they would be able to get through the filter in a septic system and out through the drain field as well. But yeah, I expect all of this to be coming probably in the next few years. We'll understand more.
Oh, fascinating and scary. um, Question here. Do you think dog waste is a significant pollutant or more of a litter issue? I have some thoughts on that too. So Jerilyn, I'd like to hear what you have to say, and then I would also like to mention
Yeah, I know that Tim has opinions about this.
that.
uh, yeah, I don't really know. I'd be interested to hear your opinions because I honestly don't know too much about that topic.
hmm well, part of my job is, or my paid job is to work with the Snohomish Conservation District, and currently we're working with a grant for called the Pollution Identification and Correction Project with the Stillaguamish River Watershed. Pet waste, specific, not necessarily dog waste, mostly because they're out walking around and they're in the yards, and that's where most of them do their business. Because of the sheer number of dogs in the region, their pet waste, when the rain hits, it melts the waste. Slugs don't eat it all, and it ends up in surface water and can end up in contributing to fecal pollution in our bays, which can affect our shellfish beds and make shellfish unsafe to eat. So that's the primary issue with shellfish and pet waste that I concern. But as far as how they affect salmon and other animals within the marine environment, I don't know as much of a connection there. The biggest connection is a health issue of fecal pollution being in the waters and making people and animals sick.
Yeah, I don't know how it ranks compared to like livestock waste or the occasional um, overflow of like a wastewater treatment plant. But the way I see it is that it does contribute and it's something that's easily remedied. So why not?
Yes, and septic systems are a huge contributor to
Yeah.
failings. You know, I shouldn't say that they're all failing, but a lot of septic systems are not working optimally, and fecal pollution from humans can end up in the water as well. We've got some thank yous. I wanted to also chat out the website for the Camano Wildlife Habitat Project if you're interested in learning some more about how to do make some changes on your property or expand the habitat that you already have on your property, and then certify it and get a sign to show your neighbors, hey, this is why I still have seed heads on my flowers all the winter long, is because it's providing habitat. So if you have questions, please let us know. Any other questions for Jerilyn? Looks like we don't have more questions, but thank you all very much for attending this evening. Um, it was sure nice to have you all on the screen. And Jerilyn, I really enjoyed your presentation. I learned a lot, and I knew some of this already, but the way you presented it and and some of the graphics are things that I had not seen before. So this was really neat, and I really appreciate it. Thank
Cool.
you very much for helping us out, keeping our Camano Wildlife Habitat community education programs going in the middle of a pandemic. So
Uh,
thank you.
will
Go ahead.
slides be available? Yes, I can make those available. And we've also
Perfect.
recorded this. So assuming that everything goes well with technology, that can be uploaded to WSU Extension Island County's YouTube, and then we can share via Facebook. So you can rewatch any portion you want, share with friends, whatever you like.
We will do that. Great. Thank you all very much. And yes, if you have any further questions, just send Jerilyn an email, or you can go to the Camano Wildlife Habitat Project website and send us an email or give us a call. We'd be happy to answer your questions. Thank you.
All right. Thanks, everybody.